I'll be discussing the concept of geometric sequences, one of the foundation of mathematical patterns. So what is geometric sequence? A geometric sequence is a series of numbers where you multiply the previous numbers by a fixed value called the common ratio to get the next number. The study of geometric sequences can be traced back to the ancient Greece. Euclid, a mathematician from around 300 before Common Era, described a geometric progressions in his book Elements. He used them to explore ratios and proportions. During the Islamic Golden Age, mathematicians like Al-Khwarizmi continued the study of these patterns which influenced modern algebra and mathematics.
Example of geometric sequence is 2, 6, 18, and 54. In this example, the first term is 2 because the common ratio is 3. Because when we divided 6 divided by 2 equals 3, and when we divided 18 divided by 6, the outcome will be 3. Same goes when we divided 54 in 18. When we divided 54 divided by 18, the outcome will be 3. So the formula to find the n term. A sub n is equal to sub 1 times r raised to n minus 1, where an, the term you want to find, and ai, or a1, is the first term, and r is the common ratio. N is the position of the terms, or sometimes number of terms. Now let's look at the example 2, 6, 18, and 54. The first term is 2, and our common ratio is 3 because when we divided 6 divided by 2, the answer is 3, and that is our common ratio. And the n term is what we call the position of the terms, or number of terms.
A geometric sequence multiplies each term by the same number, or common ratio. The formula helps you find any term in the sequence. Geometric sequences are useful in many areas like finance, physics, and computer science. And that's all. Thank you.
Transformations are everywhere in the world around us, on the way we move our bodies to the way the images are created on a computer. So imagine a separate ball and the middle of the soccer field. It moves all around the field in any direction, but it always stays the same size and shape. That's called a translation. Now, imagine you're standing in the front of the mirror. You raise your right arm and your reflection raises its left arm. You turn around and your reflection turns around. That's a reflection. Finally, imagine you're sitting in a car on a Ferris wheel. As Ferris wheel is turning the car, your riding is in taking you up, down, and around that rotation. So, these are just 3 examples of our real-world transformations. In this video, we're going to learn how to use this movement to create new image of shape.
First one is translation. Translation is a movement or slide of a shape from one place to another. It's like sliding a shape across the piece of paper. To translate the shape, you need to know the direction and the distance of the movements. If you translate or slide these orange trapezoids 3 units up and 6 units to the right, the new pink trapezoids will be 3 units up and 6 units to the right of the original orange trapezoids. In this rigid movement transformation, the orange figure slides to form the pink one, and the translated one is called image. So the pink trapezoids is translations of the orange one. So, reflection. Reflection is a flip of a shape out of the line. It's like looking at the shape in a mirror. So to reflect the shape, you need to know the line of the reflection. Like for example, if you try to reflect a triangle over a y-axis, the new triangle will be the mirror image of the original triangle. But it will be flipped over, and we can see that the orange figure or triangle figure flipped to form a pink one. And we can say that the pink one is a reflection of the orange figure. It's rotation. Now, let's look at the rotation. It is a turn of the shape around the point. It's like spinning a shape on a turntable. So, to rotate the shape, you need to know the center of the rotation and the angle of the rotation. So for example, if you rotate a trapezoid counterclockwise 90 degrees around the center edge, the new image will be turned 90 degrees to the left, or counterclockwise to the original figure or original trapezoids. So the original figure rotates 90 degrees to form pink figure. And we can say, or we say, that the pink figures or image is a rotation of the orange one.
Transformations is also used in many different areas of math, as geometric, trigonometric, and calculus. They can also be used in computer, graphic, animations, and video games.